Hello, everyone. How is everyone doing? Okay, today's the unexpected. I'll be kind of learning React from scratch. Uh, I have lots of experience with vue.js, but now that recently I'm, looking at various job postings and whatnot, I'm seeing like there is so much React. Just React, 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 React. I can understand Angular here and there, especially in enterprise. But there's just so much React, and I'm like, why is it? And there are so many new projects still created in React. So I figured, you know what? I know some concepts of React. I worked a little bit with it. But I figured, you know what? Let's kind of start from absolute scratch, see what it would be like to, what is it like to learn it from the basics and see if it really is few steps backwards. Because from my current opinion, it's like, I don't know, React is like, oh, let's make everything difficult kind of approach compared to, let's say, Vue.js. Because you need to deal with state management that, there's just like no state management. You actually need to bend yourself backwards to manage the state. Like, oh, I need tricks to actually manage state. Or, oh, I need tricks to actually make the everything not re-render itself. It's just like doing everything manually. I don't know. It's like, really? For last 15 years or something? Well, maybe not 15, last 10 years. I don't know. I just don't get it. So I figured, let's try to learn it from scratch and see what happens, right? So let's just straight up get going. So what's the best way to learn React, I wonder? Maybe we'll just do like awesome React, right? Maybe there'll be some resources here. Sure. We have general resources. Beautiful. Tutorials. React official tutorial. Okay, there we go. We found tutorial. At least that was easy, right? So, yeah, let's see what happens. Let's see how it goes. Quick start. Welcome to the React documentation. This page will give you an introduction to 80% of the React concepts that you will use on a daily basis. Okay, you'll learn how to create and nest components, how to add markup and styles, how to display data, how to render conditions and lists, how to respond to events and update the screen, and how to share data between components. All right. So let's see, creating and nesting components. React apps are made out of components. Okay, I mean, that's one of the first frameworks that, I don't know, made it like popular, I think. I'm sure there were some things before, but React was the thing, the first framework that actually exploded. A component is a piece of the UI, user interface, that has its own logic and appearance. A component can be as small as a button, or as large as an entire page. React components are JavaScript functions that return markup. Okay, so that's the first difference from like Vue.js. In Vue.js, you don't think of components as much as functions. You think often of them as some kind of object, like in Vue 2, you were with all the options API, you were literally like defining an object that has its data, has its how it's being displayed. You could do like a return thing similar to what we have here in JSX. But React is like, okay, everything is just a function, right? That will be run at some point. Okay, so we can define function by button, right? It returns, and we can just kind of shove in HTML in here. Okay, I don't like that. It looks weird, but sure. Now that you've declared my button, you can nest it into another component. And okay, so we have our button, right? So we can export another function, my app, right? So this, I guess, will be the entire app, right? And return more markup. But the thing is that we can use literally the name of the function. Okay, so I guess we can just throw in a function here, right? And it will magically turn it into a component. Okay. I mean, that's simple enough, right? Nothing crazy here. Notice that my button starts with a capital letter. That's how you know it's a React component. React components names must always start with a capital letter, while HTML tags must be lowercase. Okay, so that's interesting. So you actually have to name it with capital letters. What if you name your function with lowercase letter? It won't work. I mean, I get it as a convention, sure. Let's make things look the same everywhere. Have a look at this result. Okay, so we've got this, right? Our button, I'm a button, so just this is the component. So I might as well just do my button, right? The second button, I have two of them. And I'm a thing, and they both should change, right? Because we're reusing it. What if I'm gonna make a lowercase? Error. What if I'm gonna make those lowercase? Error. Look at that. So we are for sorry about that. So, okay, so we are officially forced to name functions with capital letters. Weird for JavaScript, but okay. I guess, this is realm of React. This is the convention. So I can live with that. Simple enough. So the export default keywords specify the main components in the file. Okay, the main component. Oh, so we can consider that this is one file, right? And, we're exporting the default component. So that's normal, right? I'm sure we can export multiple. If you're not familiar with some piece of JavaScript syntax, MDN and javascript.info have great references. Never heard of javascript.info, huh? Writing markup with JSX. The markup syntax you've seen above is called JSX. It is optional, but most React projects use JSX for its convenience. Yeah, I heard that if you don't want to use JSX, you need to use like create element, and it gets really, really, really repetitive because it's like building stuff manually. You build HTML without HTML at that point. All of the tools we recommend for local development support JSX out of the box. JSX is stricter than HTML. You have to close tags like BR, breakline, like whatever, break. Your component also can't return multiple JSX tags. You have to wrap them into a shared parent, like a div or an empty wrapper. Is it like fragment, right? Okay, there we go. We use the fragment because we want to return two things. So in theory, if I wanted to return a button and right after that, I don't know, exclamation mark or whatever, like a smiley face, now I have error. We would need to wrap it in this thing. Whoa. Why didn't it copy? Right, and there we go. There we go. A component that returns two things, and because these are not like, if I would make it into a div, I guess it will still work out with a display under each other. Yeah, see, they display under each other. I would need to do a span, and then you're dealing with like having that extra span. Maybe your CSS stopped working. This will actually, properly do things. So yeah, that's simple. In vue.js, that this kind of thing is just template. You would just template, and you have the same result. Okay, makes sense. So what's next? If you have a lot of HTML to port into JSX, you can use an online converter. Huh, Okay, I guess it will fix errors for you. So adding styles. In React, you specify a CSS class with class name. Yeah, that's where we start doing weird stuff. It works in the same way as the HTML class attribute. Okay, so the same thing. We just can't use class because I guess it gets angry with the rest of JavaScript. Yeah, we just need to do class name. Then you write the CSS rules for it in a separate CSS file. Okay, so you need a separate CSS file for that. Okay. All right. I guess. That means that next to your, I guess maybe it's more like, yeah. So basically, you need to have either shared CSS, or just separate CSS file for your different components. What if you want scoped CSS? Is that possible? Don't know. We'll learn. React does not prescribe how you add CSS files. In the simplest case, you'll add a link tag to your HTML. If you use a build tool or a framework, consult its documentation to learn how to add a CSS file to your project. Okay, so it will probably be, different frameworks will develop their own ways to add CSS. So in vue.js, for example, I would just have one .vue file that has, the how to display it, the logic, and also the styles that you can make scoped so they are like only within the component, so that the framework takes care of you making sure that things don't pollute. So, okay, we don't get that here either. You need to build entire framework around React to do that. Okay, so displaying data. JSX lets you put markup into JavaScript. Curly braces let you escape back into JavaScript so that you can embed some variable from your code and display it to the user. For example, this will display username. Okay, where do we get the username from? Okay, and single braces. Okay. You can also escape into JavaScript from JSX attributes, but you have to use curly braces instead of quotes. For example, class name avatar passes the avatar string as a CSS class, but source, this thing, we have the curly braces, reads the JavaScript, variable value, and then passes that value as the source attribute. Okay, that makes sense. That's simple enough. I wonder how props work in this case. You can put more complex expressions inside the JSX curly braces too. For example, string concatenation. Okay, so we have like a separate object in the whole file. We have name, image URL, and image size, which is an integer. So we export our profile, right? We wrap it in a fragment because we want to return more than one thing. Again, something you don't have to do that anymore in Vue.js 3. So, that's one problem solved in Vue.js already. Sorry that I will be saying so many good things about Vue.js. Unless I find something that's amazing in React, then I will be like, yeah, this is nice. Okay, so, we print the name, right? Username. We change it here to, and it updated, right? Next, we have the image. We add the class, right? Then the source of the image comes from here. And alt is photo off. Okay, here we're actually adding two strings. And style, okay, we have one curly brace to signify we're in JavaScript, and then another one to start creating an object with those two values, which will be integers. Okay, all right. And therefore, so this is like an object that holds the style, and these will be just the properties of style, just like you would do, normally. Style is width, right? and whatever, 90, right? And then you would do height 90. Probably pixels you would want to put in here. This thing doesn't specify it, so I guess it defaults to pixels, right? And now this will be unhappy because receive true for a non-boolean attribute s. What am I doing wrong? Because I have two styles, right? No. Would I break? Receive true for an STY. Can you like refresh? Select everything, reset, paste the new one in. I remove that and still broken? No, I mean, it's good, right? Yeah. Expect a mapping from style. Okay, I guess if I specify style here, I actually need to specify in this way. I can't specify it in the old string way. Huh. That's an interesting one. So we have some additional limitations. Okay. Good to know. So in the above example, style is not a special syntax, but regular, exactly, JavaScript object inside of style, bam, JSX curly braces. You can use the style attribute when your styles depend on JavaScript variables. What if they don't depend? Looks like I couldn't do it just with a string, so what? Not only when, always. Conditional rendering. Okay, now we're going into where frameworks become a little bit more useful. In React, adding actual logic. In React, there is no special syntax for writing conditions. Instead, you'll use the same techniques as you use when writing regular JavaScript code. For example, you can use an if statement to conditionally include JSX. So content, and if is logged in, content will be this. Otherwise, it'll be that. I wonder how JSX figures out that it's, we're dealing with HTML here or whatever. I guess because it detects tags and nothing else in the language uses something like that. Maybe. And then we can return whatever this was, right? This is JavaScript, and we just return the content which holds this thing. I mean, renders it, I guess, right? Okay, that's simple enough. But we want to do it in runtime, right? If you prefer more compact code, you can use conditional. What the hell was this name? I keep forgetting the name of this. Ternary, there we go. The ternary operator. Unlike if, it works inside of JSX. Okay, so if statements don't work inside of JSX, you have to use ternary. Oh, that's great for readability, right? Okay. So if it's logged in, right, we do this. Oh, we need to throw in parentheses. That's great. And then this, we need to throw in more parentheses. Okay. I mean, for this example, it's simple, but what if you have something more complex? I think it's gonna be like really hard to read. But at the same time, I don't think it's any worse than what Vue.js has, where it's so easy to skip those. Don't know. So when you don't need the else branch, you can also use a shorter logical and syntax. So if it's logged in and, so this is true, right? If this is true, the next part will execute, right? Bam. But because JavaScript, short circuits the binary operators, whatever, Boolean operators, if this is false, it won't even bother executing this one. All of those approaches also work for conditionally specifying attributes. If you're unfamiliar with some of this JavaScript syntax, you can start always using if else. So rendering lists. Okay, I guess we're gonna have some kind of key. You'll rely on JavaScript features like for loop and array map function to render lists of components. For example, let's say you have an array of products. Bam. Bam. So we have cabbage, garlic, and apple, and they each have their ID. That will be the key, probably. Inside your component, use the map function to transform an array of products into an array of list items. Okay, so we take our list items and we're gonna map over our products. And we'll just create a list item. There we go, with a key of ID. And inside of that, we just print out as a normal string our title. And this way, we'll just produce multiples of those list item elements. And we can then just throw them in here. And that's it. Okay, that's simple. So I already see the key will be just so that React can differentiate between each entry to see which one to update when rendering. But I think React uses the shadow DOM or a virtual DOM. So it's going to render them anyway and then compare if it actually needs to render them, you know, in the actual DOM. I guess. Yeah, sure. We don't know as much on the inner workings of it yet. Hey, Taras, how are you doing? What brings you here? Notice how list item has a key attribute. For each item in the list, you should pass a string or a number that uniquely identifies that item among its siblings. Usually a key should be coming from your data, such as database ID. React uses your keys to know what happened if you later insert, delete, or reorder items. And there we go. We added our elements, right? We just can add to our list, maybe title. What else can you buy in a store? I don't know, cabbage, garlic, apple. So maybe toilet brush, right? Is fruit false, and ID will be, I don't know, 69. There you go. And there we go. We've got our thing. If we would make it a fruit, it'll be different color because this is our main component, right? So inside a component, instead of doing instantly return, we can, you know, do our calculations. So we create our list items, do all this stuff. We map the products. Okay, so key is this and style. So we do the color, and here we have our ternary to decide on the color. Okay, that's simple enough. And then the title, and then we print them out. So first thing I think of is like, okay, this is inside a function. This is not some kind of object that's going to be cached. It's an actual function that we execute. And I don't think this is smart enough to analyze the function and extract, like, you know what, we need to keep track of those list items or something. It probably just blindly goes and executes the whole thing. That means every time we need to render shopping list, it's going to run all of this code and then render it. Oh, geez. I mean, that sounds like a lot of unnecessary work. That says, when is Pico CSS? What brings me here? Link from WhatsApp. Yes. If you're not interested in React, you don't have to watch. Pico CSS, I don't know if we're going to use it in this one. I'm just literally going from scratch with React and reacting to how backwards it is so far. It's very backwards. Unless the beginnings are backwards and then it's suddenly something more interesting. I don't know, but this is kind of disappointing so far. Okay, responding to events. You can respond to events by declaring event handler functions inside your components. Okay, so we have our component, right? So we define handle click, and that will be the alert. All right. Return our button, and we can do onClick and point it to this function. Okay, that's nice. I like that you can still include it just inside of your functions. And I guess because we execute that, this captures this entirety of this and somehow works. Okay, all right. Sure. Notice how onClick equals handle click has no parentheses at the end. Yeah, we're passing the function, not the executing it. Do not call the event handler function. You only need to pass it down. React will call your event handler when the user clicks the button. So this brings me instantly to, what if we're gonna make like some kind of other handler for, I know, onClick, right? But we actually call it and it just console logs. Does it mean that we'll know every time a component re-renders? Probably we'll know how many times we actually run this code from scratch. Okay. I mean, this is simple. So let's go further because, I mean, this goes like, bam, 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 quick things, right? But it looks like there will be tutorial tic-tac-toe, so I guess we'll implement something soon because we're already halfway through it. I mean, it's going fast, but nothing crazy so far. So updating the screen. Often you want your component to remember some information and display it. Oh, look at that, yeah. For example, maybe you want to count the number of times a button is clicked. To do this, add state to your component. First, import useState from React. Okay, so this is so-called React hooks, right? Import useState from React. No biggie. Now we can declare a state variable inside our component. Okay, so it's like optional feature. Interesting. So constant count, set count, useState 0. So this looks like when we call that, hey, we want a state probably with initial state of number 0, and we get from that a list of functions and things. So we get a list of first the actual value, which will be 0 in the beginning, and then an extra method or function to actually change it. So you can't change this directly. You actually need to call set count manually to update it. Okay, so like a callback. All right. You'll get two things from useState: the current state count and a function that lets you update it, as in the set count. You can give them any names, but the convention is to write something and set something. Yep, so that it's clear throughout the code. The first time the button is displayed, count will be 0 because you passed 0 to useState. When you want to change state, call setCount and pass the new value to it. Clicking this button will increment the counter. Okay, so we've got an actual example, right? So we have our state of count and setCount. Our handle click will be just, set count and increases. Uses this within here. Okay. And when we render it, we'll just render a button with, what happens when you click it. Bam. And clicked how many times, it will just display it here. There you go. And React will call your component function again. This time count will be 1, and then it will be 2, and so on. If you render the same component multiple times, each will give its own state. Click each button separately. Okay, so looks like we have our, the same thing, right? With our button. We just render it twice. So each one is separate, right? Each one has its own state. Its own instance tracks it. Okay, I mean, that's simple enough. Yep. Great. That's simple. Okay, so I like the use state. This is similar to what you can do in vue.js. You would use, maybe not exactly like that with hooks. With those hooks, you would probably use when working with something like Pina, which is like the whole state management. where you can kind of do that. The only thing in vue.js is that you don't have a separate set count. You just assign a value to your count, like count equals something, and it will just work. There's some weird shenanigans of when to use value and not, which I don't like. Something like Svelte solves that problem. But okay, this is simple. You just need to get used to that. Okay, this is in theory unmutable, at least throughout the render it happens and then it forgets it, while set count allows you to actually change it and trigger the re-render, I presume. Okay, so let's say that, what happens if I'm gonna do on click, right? We're gonna do something like log render. I want to see what happens. So const log render, and we'll just do what? Console log main component or whatever. Let's call it parent re-rendered. Wait, we have that, right? Parent re-rendered. Parent re-rendered. So every time I click that, the actual parent re-renders. Why? Why do you need to run this entire code from scratch when only one button re-rendered? There's nothing else depends on that. Just that part could re-render. Okay, that's kind of stupid. I guess that's React, right? Everything re-renders way too many times. Okay, disappointing. Okay, so notice how each button remembers its own count state and doesn't affect other buttons. So using hooks. Functions starting with use are called hooks. UseState is a built-in hook provided by React. You can find other built-in hooks in the API reference. You can also write your own hooks by combining the existing ones. I mean, I can see them being extremely simple, right? Because when you call this, I guess it has somewhere an object or a list of objects that it stores, right? And it just stores the initial value and sends you back something to whatever. Just update that value in that one shared object and it just holds it for you, right? But what happens, how does it manage when component is not there anymore? Does it delete it automatically? I'd presume it needs to know how to do that. So it probably has some kind of logic behind the scenes to kind of bind your component to the actual state. I really wonder how does it manage that memory, or is it like there forever and when you create and destroy a bunch of unique ones it just keeps building up or something? Curious. Yeah, I want to know. What the hell? Go away. How does the use state work behind the scenes in React? Because it seems like very simple, but there's just so many conditions that it's interesting. So React use state implementation relies on several key mechanisms working together. So fiber architecture and hook storage. React stores hook state in a fiber node representing each component instance. Each fiber maintains a memoized state property that forms a linked list of hook objects. Okay, so we have that, basically those lists, right? So if type hook, memoized state, whatever can hold whatever, base state for updates, pending updates, update queue, and next hook on the list. Okay, great. Hook indexing and call order. React relies on call order rather than keys to match hooks between renders. Oh wow, okay. Interesting. During the first render, React creates hooks sequentially and stores them in the linked list. On the subsequent renders, it traverses the same list in order. So if you're gonna swap two elements, we'll ignore the keys. I mean, it has probably some extra mechanism, right? Simplified dispatcher logic, current hook, work in progress hook. And we have our use state, right? Of initial state, and then we have the state and dispatch of set state action. Okay. We create this hook, which is update work in progress hook. Get next hook from the list, right? First render, initialize. So if it's not yet memoized, it basically type of initial state. If it's a function, then initial state. If it's not, it just uses it. Oh, so if it's a function, it calls it. If not, I guess it's an object. Okay. And then return the memoized state and binds it. Okay. Null to hook queue. Okay. All right. Something. Whatever this is. Okay. Update queue and batching. State updates don't happen immediately. Instead, they're queued and processed during the next render cycle. So we have update, right, and goes through them, dispatch action, add to queue, reconciliation process. The reconciliation React processes the update queue to compute the new state. Okay, I'll ignore all that. So, in plain language, how does the use state know when to delete stored data after the component has been destroyed? No longer rendered. Or maybe it doesn't. So it automatically cleans up use state data through its component lifecycle management. It's tied directly to when a component instant gets destroyed. Okay, so it has those hooks. I mean, whatever, the lifecycle management, so it probably hooks into that. So I guess whenever we call it first time, it somehow detects that, okay, since all hook state lives directly on the fiber node, in that memoized state linked list I mentioned, when React garbage collects the fiber node, all the hook state goes with it. Oh, okay. So basically we can imagine that, I guess the fiber node is the virtual DOM node, right? So when it renders it, right, it probably keeps track. Okay, I need to render this component now. So I'm gonna create the virtual node. And by the time we're actually calling things like use hook or whatever, it knows what the current node that it's rendering is. So that use state will be executed on that node. And therefore all that state is kind of attached to the node. So the order and all the stuff doesn't matter. Okay, and then when we destroy the node, the state goes with it. Okay, all right, that works. I'm satisfied with that. Okay, great. So let's continue. Enough of that diversion. And I'm making a lot of assumptions here. Okay, so we did go through that using the hooks, right? You can find other built-in hooks via the API reference. You can also write your own. Hooks are more restrictive than other functions. You can only call hooks on the top of your components or other hooks. If you want to use useState in a condition or loop, extract a new component and put it in there. Okay, because I guess it needs to happen before we're rendering, and it needs to be attached to that node, right? So sharing data between components. Now, okay, we're advancing. We're moving forward. We have basic state, now how to share it between, because without that, you can't do much. In the previous example, each My button had its own independent count. And when each button was clicked, only the count for the button clicked changed. Okay, because we have our app, we clicked this one, so only this one changed, right? However, often you'll need components to share data and always update together. To make both my button components display the same count and update together, you need to move the state from the individual button upwards to the closest component containing all of them. In this case, it would be my app. So the idea is that the my app holds the count, right? And the count is passed into the buttons so that they know what to display. Okay. So initially my app's count state is 0 and it's passed down both children. On click, my app updates its count state to 1 and passes down to both children. So I guess we'll have two options here. Either because we'll be able to pass something to my button. We'll need to pass the current count so that they can display it. And I wonder if, I mean, we can have probably two options. One option would be to do something where, oh, we're also going to pass that set count function. Therefore, my button can just set it itself and everything should magically update. Or we probably can trigger some kind of event that we'll be able to hook into on the my app side. So let's see what they recommend. Now, when I click either button, the count in my app will change, which will change both the counts in my button. Here's how you can express it in code. First, move the state up from my button to my app. Okay, now my app has the use state. Okay, great. So we removed it from here. Then pass the state down from my app to each my button, together with the shared click handler. You can pass information to my button using the JSX curly braces, just like you previously did with built-in tags, like the IMG. So yeah, we literally created an attribute count and threw it in there, right? That's simple. But look at that. We also defined on click on it. So we'll be detecting when my button gets clicked somehow. So the information you pass down like this is called props. Now the my app component contains the count state and the handle click event handler and passes both of them down as props to each of the buttons. Finally, change my button to read the props you have passed down from its components. So we have the my button. We can define, okay, it takes in an object that will hold both count and on click. Oh, so okay. So we literally passed this function as a function here. Okay, that's simple. I like that. No weird stuff with events or anything. It's just a callback that we can execute. And here in our on click, we just pass on this one. We connect them, so when this gets clicked, it triggers this callback, which is activating ultimately this one. Okay, that's simple enough. I can deal with that. And yeah, there you go. That's it. Are these optional? How does that work? Can I, like do stuff? I guess we'll experiment. When I click the button, the on-click handler fires. Each button's on-click prop was set to the handle click function inside my app. So the code inside of it runs. That code calls setCount, count plus 1, incrementing the count state variable. The new count value is passed as a prop to each button, so they all show the new value. This is called lifting state up. By moving state up, you've shared it between components. Okay, so we have exactly that. We use state, we have my app, which holds the state for count and has the handle click. And then we render it exactly like in the example above. And my button now is like really dumb. The only thing is it calls this when I clicked and displays the count just like it did before. It just reads it from here. Okay. All right. So now they both, I click one and they all update. So that's simple enough. Very simple, I'd say. Okay. I like that. I wonder if I could just say props. That's probably the old style, right? And I do, because it's an object, I can call it whatever I want here, right? And props dot this, and it will just work. Okay, that's great. So what happens if I'm just gonna do this? Okay, so it just probably reads undefined and it's fine. So we are not enforcing that one of them exists. But if we wanted to, oh, wait a moment. Yeah, because we defined this as onClick. If we're gonna do this as count, what the hell's gonna happen? Count. Nothing. It's just not happy. Okay, all right. This is simple enough. And because we just pass like that, it doesn't matter what structure is here. All right. No need for events. I can live with that. I guess you could do that in vue.js. I just never thought about throwing in callbacks. I guess it's not very idiomatic, and that's the thing. Okay, so we went through like bare bones basics. By now, you know the basics of how to write React code. Check out the tutorial to put them into practice and build your first mini app with React. So let's go to the tutorial, tic-tac-toe. You will build a small tic-tac-toe game during this tutorial. This tutorial does not assume any existing React knowledge. The techniques you'll learn in the tutorial are fundamental to building any React app, and fully understanding it will give you a deep understanding of React. Note, this tutorial is designed for people who prefer to learn by doing and want to quickly try making something tangible. If you prefer learning each concept step by step, start with describing the UI. Let's just do this. We learn a bunch of concepts, so let's actually do something with it. Because just by reading, we won't learn much for long. The tutorial, it's like humans are a little bit like LLMs. We have some kind of context window so that as I'm reading this whole stuff now, I'm kind of remembering that it was this thing, this, that, and that. But if I keep reading and reading, I'll start forgetting the previous stuff, the old stuff, because I kind of didn't refresh it yet. And we need to keep kind of reinforcing that, not just by reading, but actually using that knowledge in some other ways to start building the connections. So this tutorial is divided into several actions. Set up the tutorial will give you a starting point to follow the tutorial. Overview will teach you the fundamentals of React components, props, and state. I thought we already did that. Completing the game will teach you the most common techniques in React development, and adding time travel will give you a deeper insight into the unique strengths of React. Oh, I want to know the unique strength of React. So that's awesome. I want to know if it can do anything good to me. So far, it seems a little bit limiting. I don't know. I guess because I'm used to the Vue way of things. So they're building. In this tutorial, we'll build an interactive tic-tac-toe game with React. You can see what it will look like when you're finished here. How much code there is? Not much. So, yep. And we have a list of what happened, right? And winner. There we go. And we can kind of time travel back to game start and start from here. Okay, I guess that takes care of restarting the game. What am I doing? Why am I playing? No winners. There you go. All right. If the code doesn't make sense to you yet, it will, or if you're unfamiliar with the code syntax, don't worry. The goal of this tutorial is to help you understand React and its syntax. We recommend that you check out the tic-tac-toe game above before continuing with the tutorial. One of the features that you'll notice is that there is a numbered list to the right of the game's board. This list gives you a history of all the moves that have occurred in the game, and it is updated as the game progresses. Once you've played around with the finished tic-tac-toe game, keep scrolling. You'll start with a simpler template in this tutorial. Our next step is to set you up so that you can start building the game. So set up for the tutorial. In the live code editor below, click fork in the top right corner to open the editor in a new tab using the website Code Sandbox. Code Sandbox lets you write code in your browser and preview how your users will see the app you've created. The new tab should display an empty square and a starter code for this tutorial. Okay, so let's fork it and see what happens. There we go. We, I guess, need to zoom in a little bit for the sake of tutorial. So we have basically VS Code, right? We have our app.js and we have a bunch of other stuff. We have our package.json with, we have three packages, React, React DOM, and React scripts, okay? All right, in public, we just have our index, which kind of gives us the base HTML, index.js, which sets up our app, and we have some built-in styles to kind of make it work. Okay, and because of that, in our app.js, we basically create this. I'm actually tempted to recreate something like that in vue.js that we can edit concurrently. So can I take it out of here? How do I take it out of here? I don't want this. I want it in a separate page. There we go. So we've got this. Let's put it on a second screen. So we have this one here, and let's go to a third one, and maybe we're gonna do, what is it? Zen browser, right? Okay, it opens as a new one. Code sandbox. Maybe we have a like Vue.js template. Resources, templates, there we go. Front end, and we want Vue 3. Beautiful. I just want to see the template. Is that like, what kind of template is that? Whoa, this is a big template. Holy moly. Okay, Vue and a little counter. We have TypeScript straight up. Okay, wow, this is a comprehensive. Okay. And how are the components written? I'm just quickly checking it out. So we have our app view, right? Okay, we've got script set up. So that's good enough. I can live with that. All right, so we can build them side by side. This we can just hide because we don't need it. We'll be doing everything here. We won't be doing anything with styles here, so I'm just gonna remove the styles to make the whole, oh, first we need to fork it, right? We can't just fork it. Back. Take me back. Fork template. There we go. So first of all, we remove all the styles. You go away. Quick cleanup. Sign in. Oh, seriously? Oh dear. GitHub, there we go. Yeah. There we go. And how about here? I need to sign in as well, right? Can I just refresh? Where's refresh in this browser? Okay, we're logged in. Here we're logged in as well, so I can delete this. Let's have our auto refresh. What the heck is going on? Code sandbox, not a good first impression. It's thinking, opening everything at once. Go away with welcome to view. You want to install extension. Why wouldn't I have that installed? It is installed already. What are they talking about? Error. At least one template or script. Oh, did I like... Wait, why is everything gone? And let's script the... let's screw the Screw all the TypeScript, we're just gonna do JavaScript, okay? And template. And what did they do here? Just a button with class name square. So in this case, I would just do button class square, okay? And we have the content to be X. There we go, save, and that should, there we go, we have our X, that's it. That's all we have. Let's just take care of the weird styles. We don't need all this. Delete, okay, save, and now we have the beautiful ugly button. So we're gonna copy the styles from here to have exactly everything the same. Save, and there we go, we've got the same thing. That should be enough of the setup, but you can see in comparison that here we have our logic, and here we have our template, our whatever, HTML that looks just like HTML. There's no difference, at least at this moment. So, okay, let's continue with the tutorial. We just set it up. You can also follow this tutorial using local development. Yeah, let's skip that. Overview. Now that you're all set up, let's get an overview of React. Inspecting the starter code. In Code Sandbox, you'll see 3 main sections. Yeah, the files. I mean, this is just VS Code. The browser section. Okay, the app.js file should be selected in the file section. The contents of that file is the code editor. It should be basically this. Yeah, so we have that. The browser section should be displaying the square with an X. Now let's have a look. So we have the app.js. The code in app.js creates a component. In React, a component is a piece of reusable code that represents a part of a user interface. Components are used to render, manage, and update the UI elements in your application. Let's look at the component line by line and see what's going on. Oh, wow. Why didn't we start with that one? Export the default function. Yep, so we define a function called squared. Export JavaScript keyword makes this function accessible outside of this file. The default keyword tells other files using your code that it's a main function in your file. And then we have all this. The second line returns a button. The return JavaScript keyword means whatever comes after is returned as a value to the color of the function. I mean, it's JavaScript, of course, yeah. And this is a JSX element. It's a combination of JavaScript code and HTML tags that describes what you like to display. Class name square is a button property or prop that tells CSS how to style the button. X is the text displayed inside the button. And this closes the JSX element to indicate that any following content shouldn't be placed inside the button. Yep. Then we've got style CSS. Okay, we went through that. This file defines the styles of your React app. The first 2 CSS selector, everything and body define the style of large parts of your app, while the square selector defines the style of any component where the class name property is set to square, or just, the class is set to square. In your code, that would match the button from the square component in the app.js file. Exactly. So if we're gonna make it that it's square, it reverts back to normal because it couldn't find that. So that's the main difference. And here we need to call it by class name. Here we can just do normal HTML stuff, which is class. So index.js, click on the file label index.js in the file section of Code Sandbox. You won't be editing this file during the tutorial, but this is the bridge between the component you created and the app.js file in the web browser. So we have import strict mode from React, import create root from React DOM client. So I guess this will be our root component, the main thing that we're rendering. We import our styles, and therefore we can just import our app component. So line 1 to 5 bring the necessary pieces together. React's library to talk to the web browser, which is React DOM. Okay, so I guess without that, just won't. The styles for your components and the components you created in app.js. Yep. The remainder of the file brings all the pieces together and injects the final product into index.html in the public folder. So let's take a look. So we have our index.js, right? We import our app. What's up with this? And then we have basically, we create a root element, right? And I guess we tell where, right? What will be the container? So the container will be just, we find the root element in our HTML page and we just render our app inside of whatever it is called a strict mode. Okay. So let's look at our HTML. Do we have it? Yeah, we have index HTML. So in here we have just our head, nothing crazy here. And we have our body. Bam. Wait, where are we placing our index? Not here. Not here. Not here. Not here. Look at that. We don't have it. We just have ID. We don't have an index. I guess this is what some kind of build process will do. What the heck? What am I missing? I guess the encompassing something here might be React scripts. Oh, that's what it is. React scripts. Because when we started or like test or whatever, we call React scripts, and that probably has the start, which will combine the two. Like, hey, I need to now start a little server that will take our index.js and index.html, inject that index into here somewhere so that it can hook itself to here. Because when I right click, inspect, really? Holy macaroni. Head has the script. I know it's tiny on a screen, on a stream. I guess, yeah, it just builds it somewhere here. Yep. This might be it. Don't know. Whatever. I assume it works that way. We don't have to touch those. So building the board, let's get back to app.js. This is where you'll spend the rest of the tutorial. Okay, currently the board is only a single square, but you need 9. If you just try to copy paste our square to make 2 squares like this, I'll complain because this cannot contain 2 elements. Yeah, adjacent JSX elements must be wrapped in an enclosing tag. React components need to return a single JSX element, not multiple adjacent JSX elements like 2 buttons. To fix this, you can wrap those fragments to wrap multiple adjacent elements, right? So we can do this. So here we can literally probably make it even larger a little bit. So instead of returning this, we're gonna do this. So we opened it there and we just have to close it here. Wait, do I need to wrap it in parentheses? Yes. Oh, it did that for me. Look at that. Oh, it just, okay, I exited and reformatted it for me. So now I can just make 2. So we'll have X and Y. And why do I have those? There we go. Well, here in vue.js, I could just do this and have X and Y. And that's it. Save. I don't have to create that extra thing because we are already in one of those. So that's nice thing. No need for those extra steps. Okay, so we did that. Now you should see this. Great, now you just need to copy paste a few times to add 9 squares and bam. Oh no, the squares are all in a single line, not in a grid like you need for our board. To fix this, you'll need to group your squares into rows with a div, with divs, and add some CSS classes. While you're at it, you'll give each square a number to make sure you know where each square is displayed. So in the app.js file, update your square. So we just need to make few divs with a class name board row and give it, like, instead of displaying X, we'll just display a number. Board row. Okay. So we still need to be inside this thing. So we're just gonna do div class name is board row, right? And that will be end of our div. And we can just move, let's say, single one, and we'll just say this is 1, 2, 3. 2 and 3. There we go. So we've got our first one. And we just copy it 2 more times. So this will be 4, 5, and 6. This will be 7, 8, and 9. There we go. So I guess this is what they want, right? Yeah. So let's do the same thing in vue.js. We'll just have our div with class board row, right? And we'll have our 1, 2, and 3. And we just need to copy 2 more times. 4, 5, 6, 7, 8, 9. We have auto formatting here. No, we don't. But there we go. Okay, so we've got pretty much the same thing. Notice how this is nearly the same as in here. It's pretty much the same. The only difference is that, you know, our class name is being used rather than just class. Okay, great. The CSS define install CSS styles, the divs with the class name of board row. And now that you've grouped your components to rows with the style divs, you have your tic-tac-toe board. There we go. But now, you now have a problem. Your component named square really isn't a square anymore. Let's fix that by changing the name to board. Oh, look at that. So we're gonna rename it to board. Okay. And that will probably break it. I know, because app.js is app.js and still default function. So that's that. And here we don't even have a concept of a name. It's just our app view. So yeah, there you go. So at this point, your code should look like this. Yep, exactly. Simple enough. Psst. That's a lot to type. It's okay to copy and paste code from this page. However, if you're up to a little challenge, recommend only copying code that you're manually typed at least once yourself. Yeah, I prefer to type too, so that, you know, it stays here. So passing data through props. Next, you'll want to change the value of a square from empty to X when the user clicks on a square. With how you've built the board so far, you would need to copy paste the code that updates the squares 9 times, once for each square you have. Instead of copy pasting, React component architecture allows you to create a reusable component to avoid messy duplicated code. First, you're going to copy the line defining your first square. Bam. From your board component to a new square component. Okay, so above that, we just define our new square component. We'll do it all within one file, old school. So it will be, they make it constant? No, just function. Function, and they called it square, right? Yeah. Okay, and this will be return. And we just copy this guy. Bam. And save. And then hence request failed, file not open in the editor. What the heck? I mean, that's it. Yeah, we've got that one. So let's do the same here. So in here, we're just gonna go a little bit nicer. Inside components, we're not using theirs. We can probably just edit the hello world. So now let's just delete the hello world. New component, and it will be square.view. Script setup. This is like the setup just makes some auto magic happen. Again, we have no logic, so we, in theory, all we need to do is the template, right? And this was literally it, just like in the other one. Bam. Yeah, that's it. We've got our square. So then you'll update the board component to render that square component using JSX syntax. So there we go. We just rendered a square everywhere instead of this whole thing. So yeah, instead of all this, we can just say, hey, everywhere we have this, let's just do square. And we've got our ones everywhere. Beautiful. That's it. This literally the same thing will happen here. The only thing is, because we have a separate file, we just need to do import square from, and it will be what we do components, right? Let's not do this. There we go. And we should be able to just do square, unless something weird is going to happen. It's thinking. Nothing's happening. What's going on? Oh. Oops. Wrong file. There you go. Save it here. Failed to resolve the import. What the hell's going on? Oh, we don't need to go back. Okay. Square view. What is going on with this thing? I'll just replace that as quick as possible. This is strange stuff. Components. Square view. Wait, did I want this instead? Oh, there we go. Fixed. Okay, we've got the same thing. Note how, unlike the browser's divs, your own components, board and square, must start with a capital letter. Let's take a look. I mean, here I can really, in vue.js, I don't really have to make them capital letter. I can just make them lowercase, right? And it's still happy. But yeah, generally you want the capital letter, or maybe with dashes so that they look like real HTML, but often people just opt in for, you know what, let's make it capitalized so that there's that distinction between what is native HTML or maybe libraries that you use versus what is your code. Oh no, you lost the numbered squares you had before. Now each square says 1. To fix this, you will use props to pass the value each square to pass the value. To pass the value each square should have from the parent component, like board, to its child, square. Update the square component to read the value prop that you'll pass from the board. Okay. So in our square, we're just gonna read the value, right? To display. Wait, not here. Oh yeah, and I forgot we have the same. And this will be probably just value, right? I presume that they didn't go that far yet, actually. Okay. Just answer something. Okay, so we have this. Now the function square value indicates the square component can be passed a prop value. Now you want to display the value instead of 1 inside every square. Try doing this. So we basically put in the value and it will be nope. It will just print the value. Yeah, you already learned. You wanted to render JavaScript variable called value from your component, not the word value. To escape into JavaScript from the JSX, you need curly braces. Add curly braces around value in JSX like so. And we just do that, and there we go. So for now, we should see the empty board, right? We do that, and yes, we see our empty board because I guess we're not receiving that value yet. This is because the board component hasn't passed the value prop to each square component it renders. Wait, this is because the board component hasn't passed the value prop to each square component it renders yet. They should work on those sentences to at least put some commas in there. To fix it, you'll add the value prop to each square component rendered by the board component. Exactly. So inside of each one, we need to just say value, 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 value. We could have done that from the beginning rather than getting rid of everything. So it'll be value equals, and we do, wait, we're supposed to do in quotes 1. So we'll do 2, 3, 4, 5, 6. I don't like how it updates before I even save the file. This is creepy. I guess that's the idea of the code sandbox, right? There we go. So we did that. Okay. So now let's implement the same thing in vue.js. It's going to be, this is going to be where it's going to be a little bit more, require more effort than what you have to do in React somehow. But in my opinion, it's kind of worth it. I don't know. So we'll just define the props, right? Our props, define props. And here we can basically say that in this case, we have prop value. Okay, that's all we want right now. And we can expand on it to make it, like, hey, the value should be an integer, for example. I mean, a number, or maybe a boolean, right? Or a string, or if it's required, or maybe it has default value. So basically, the moment you're doing any kind of real application, you already want those features. So yeah, so that's basically it. And then now that we have this as props, we can just display very similar, just double instead of single, and it will be our props.value and save. And now we have the same thing. It all just disappeared because we need to do the same thing that we did here. The fun thing is that we actually do it exactly the same thing. Value is 1. And we just go ahead and add it all here. And when we save it displays, we just need to update. Save it, and there we go. Okay, so we're at the same spot. So now you should see a grid of numbers again. Your updated code should look like this. Yep, we're good. Making an interactive component. Let's fill the square component with an X when you click it. Declare a function called handleClick inside of the square. Then add onClick to the props of the button. JSX element return from the square. So yeah, our button will have the onClick that points to this thing. And this is just a function here. So yeah, simple. So we're just, wait, that's not inside of, inside of square, right? Wait, did they do const? No, we can just do a regular function. Function on, wait, handle click, right? We don't pass anything to it. We just do, wait, value is X. That's what they want me to do? No, just console log clicked. Clicked. Okay, and therefore here, on each square, we will be able to pass one more. But do they want it after or before the props? After. Okay, I mean, yeah, here. So we have our button with class name. Okay, and a value. How do they want to format it? Okay, a nice way. All right, I can. This is gonna keep undoing everything for me, right? This auto formatting, it's so annoying. Okay, and on click is oh wait, we probably need to do this handle click, right? Because we just need to pass that function. Reformatted it for me anyway. Why do I even bother doing the work? It's probably prettier that they're using there. What the hell's going on here? There we go. Okay, so let's do the same thing in vue.js. In our square, we'll do pretty much the same. Hey, in this case, we're just gonna save it as constant. It will be on click. That's what we'll handle click, right? And that will take nothing. And we'll just do console log clicked. And here we're gonna do something else. Instead, I can format it myself here, so I'm gonna do that. Looks like we don't have prettier on or anything here. So we're just gonna go with that. So we'll have class square and we do at click. And that's gonna be the handle click. There we go. So a little bit different. You can notice that in Vue.js, we have the at symbol, and that basically say, hey, handle the event, handle click. So I save it, and I guess here it would show up. No. I would need to go wait, doesn't it show console or something? Nope. Open logs? Where are the logs? They're not showing. Oh dear. Okay. I guess we can't see it. Oh, that's funny. And we won't see it here either, right? In the React one. There's nothing here. Oh well, we can. So if you click on a square, you should see logs saying clicked in the console tab at the bottom of the browser section called sandbox. Bottom. No. They don't show a screenshot. Problems, open preview. And yeah. Well, whatever it is, just did. Nope. We don't even have option to show logs here. Okay, no need. I don't have that great need to check that. No big deal. We're gonna make it show something anyway in a second. So clicking the square more than once will log clicked again. A repeated console logs with the same message don't create more lines. Instead, they will show, the number. If you are following this tutorial using your local development environment, you need to open your browser's console. For example, if you're in a Chrome browser, yep. As the next step, you want the square component to remember that it got clicked and fill it with an X mark. To remember things, components use state. There we go. React provides a special function called useState that you can call from a component to let it remember things. Let's store the current value of the square in state and change it when the square is clicked. Import useState at the top of the file. Remove the value prop from the square component. Instead, add a new line at the start of the square that calls useState. Have it return a state variable called value. So there we go. Within our square, we're suddenly removing the props, right? Yeah. I'm going to replace it with this here value. Okay. So I guess we did all our work for nothing, but we learned something. And we're just going to do constant. Wait, they want a constant? Yeah. We're going to the structure value and set value from use state, and we're going to start with null. But we need to import something first, right? Use state from React. Import use state from React. Okay. So we have the value, and I guess we can, this already displays it, right? That's it. Okay. Value stores the value and set value. Stores the value, and set value is a function that can be used to change the value. The null passed to useState is used as the initial value for the state. So value here starts off equal to null. Since the square component no longer accepts props anymore, you'll remove the value prop from all 9 of your square components created by the board component. So we can clean it up again. All the value something, right? Save, and we have the same thing. It's still doing the same thing. So let's recreate that in vue.js. So in here, I'm just gonna say const value, right, is a reference to null at this point. So that means we can remove our props. Okay. Or let me just, so I can save myself typing for the future. We're just gonna do this. We have our value. For that, I need to actually import ref from view. It's very similar to React, right? Instead of view state, you just define a reference. It's kind of like a reactive value that it reacts and triggers stuff. So that's that, and suddenly we don't use props, we just extract it from the value, and that's it. So we save it, and now we have all nulls, right? Okay. Now we'll change the square to display an X when clicked. Replace the console log event with the set value X. Now your square component looks like this, and when we click it, it will actually update the value, right? Each one will update the value. So we can say in handle click, we're just gonna say set value, and we're just gonna give it X and save, and that should be it. So we click, and there we go. Each component, has its own state, so we can just fill it up. And then we can do the same thing here. In vue.js, handle click will be just value is X. Will it complain here? I don't remember. I need to do something weird. Value.value. There we go. So that's one quirk that I don't like in Vue.js personally. The fact that all those references and whatnot, they kind of need to do this .value. This is due to how JavaScript kind of deals with proxies and other stuff. So this kind of sucks. There are some ways to kind of skip that instead of reference use some other things, but I'm not gonna go into that. We're focusing on React and like bare React with bare vue.js, so that maybe some of those things that I'm complaining about React are resolved with some extra functions, extra helpers, extra libraries. So I won't be comparing, React with all those nice features added by external libraries to Vue.js added with extra libraries, right? We're gonna go with everything vanilla. Okay, so they both work, right? So by calling this set function from an onClick handler, why and here? And why this? That's not proper English. I guess. It's not like I'm a native speaker. You're telling React to re-render that square whenever its button is clicked. After the update, the square's value will be X, so you'll see the X on the game board. Click on any square and X should show up. Yep, each square has its own state. The value stored in each square is completely independent of the others. When you call the set function in a component, React automatically updates the child components inside too. After you've made the above changes, your code will look like this. And we just got this, right? You state, and yep, everything looks pretty much the same. Okay, great. React Developer Tools. React Dev Tools let you check the props and the state of your React components. You can find the React DevTools tab at the bottom of the browser section in Code Sandbox. React DevTools. Something tells me I won't have it. Yep, I don't have it. Inlay hints request failed. What the hell is this? File not open in editor. Okay, this is like buggy. Something's not working here. I don't have those things. Open preview. I mean, I have the preview. I'll make it smaller. Doesn't help either. Oh well. Yeah, this is buggy. Whatever. We'll live without it. But okay, we can. Okay. In the dev tools, basically, we can click something. We can see props, hooks, rendered by. We have exactly the same thing in Vue.js. To inspect a particular component on screen, use the button at the top left corner of React Dev Tools. Yep. Okay, so you're teaching us that. For local development, React Dev Tools is available as Chrome, Firefox, and Edge browser extension. Install it. Yes. So completing the game. And by this point, you have all the basic building blocks of your tic-tac-toe game. To have a complete game, you now need to alternate placing X's and O's on the board. And you need a way to determine a winner. So lifting the state up. Currently, each square component maintains a part of the game's state. To check for a winner in a tic-tac-toe game, the board would need to somehow know the state of each of the 9 square components. How would you approach that? At first, you might guess that the board needs to ask each square for that square state. Although this approach is technically possible in React, we discourage it because the code becomes difficult to understand, susceptible to bugs, and hard to refactor. Instead, the best approach is to store the game state in the parent board component instead of in each square. The board component can tell each square what to display by passing a prop, like you did when you passed a number to each square. Okay, so we're doing basically a very similar thing. Okay. To collect data from multiple children or to have 2 child components communicate with each other, declare the shared state in their parent component instead. The parent component can pass that state back down to the children via props. This keeps the child component in sync with each other and with their parent. Lifting state to parent component is common when React components are refactored. Yeah, so let's take the opportunity to try it out. Edit the board component so that it declares state variable named squares that defaults to an array of 9 nulls corresponding to the 9 squares. Okay, so we basically say, hey, we're gonna do this. Array 9 fill with nulls. We're gonna copy that part. I mean, we can just copy this. I don't feel like typing that particular thing in. So this will be in our board, in our main component. We just paste that in, right? So we can, in theory, do the same thing. I'm just gonna copy this. We want it to be squares. Whoa, reload window. Please don't tell me this all got lost. It didn't. Okay. App. So in our app, in our script, which is our logic, we're just gonna say constant squares. Whoa. What the hell? And we're just gonna say again reference, just like we did before. And this will be our initial value. So we just need to do import ref from view. And that's it. So we've got that part. We've got this thing done. And we have our use state already here, shared from the other file. Great. So now the array 9 fill null creates an array with 9 elements and sets each of them to null. The use state call around it declares the squares state variable that's initially set to that array. Each entry in the array corresponds to the value of the square. When you fill the board in later, the squares array will look like this. Bam. Yep, all this maybe has O, this has an X, right? And these are not set yet. Now your board component needs to pass the value prop down to each square that it renders. So we're going back to having value something. But in this case, we just extract the thing from the square. So we're not passing entire array to each component. We're passing just the value it needs. Okay. So in here, we're just going to say that our squares will have a value is, in this case, will be squares. And yeah, we'll need to just do 0, 1, 2, 3, whoopsie, 4, 5, and 6, 7, and 8. And that's it. That's it. We save it. These buttons don't care yet. Well, there's something new I'm getting. And that's it. So let's do the same here. Where? I was still passing those values even though we don't care about them. So look at that. We can actually do something very similar. Let's just get this going. And we're gonna make it where we actually want it kind of reactive. So instead of doing the double square brackets, we're just gonna put colon in front, and we can still do that. But now everything within the quotes is JavaScript. So it's kind of similar, kind of not. And now we can do squares and provide that value. And this is all happy. But again, we're not displaying it because the square itself isn't aware of it yet. That's why it's good we saved this. Okay, great. Next, you'll edit the square component to receive the value prop from the board component. This will require removing the squares component's own stateful tracking of value and the button onClick prop. So yeah, we simplify that. We just had the value, and the onClick we just removed, but we'll be adding the onClick in a second. So I'm gonna save it for now because I know what's gonna happen later. So here in our square, we're not doing this anymore, okay? Our handle click will be just nothing. But we're receiving the value, okay? That's what we're taking in here. And therefore, we need to display it, right? It's all nulls, so it's fine. Unless I'm going to go and define them as not null, but maybe high, right? Now we have all the highs, so that works. Okay, should work here as well. If I'm gonna, I mean, we need to hook it up, right? So now I'm gonna say again, hey, we need to get the value. Therefore, we are not doing this anymore. We're just gonna say that we display the props dot value, right? Nothing crazy here. And that's it. Handle click will not set that value because that will be weird. And we save it. And therefore, if I'm gonna go here and say hi, we got all the highs. Why did I number them from 1? Oh no, insert doesn't work here. 0, 1, 2, 3, 4, 5, 6, 7, 8. There we go. Now it's fixed. Look at that. We found a bug. Okay, so we have equivalent code now. So at this point, you should see an empty tic-tac-toe board, and your code should look like this. Each square will now receive a value prop that will either be X, O, or null for empty squares. Next, you need to change what happens when a square is clicked. The board component now maintains which squares are filled. You'll need to create a way for the square to update the board state. Since state is private to the component that defines it, you cannot update the board state directly from square. Instead, you'll pass down a function from the board component to the square component. And you'll have square call a function when square is clicked. You'll start with a function that the square component will call when it's clicked. You'll call that function on square click. So yeah, square click on square click. Next, you'll add on square click function to the square component's props, exactly, so that we can click on it. And now you'll connect the on square click prop to a function in the board component that you'll name handle click. So let's just do that part. On square click, right? So we have the prop on square click. Okay. And instead of doing this, we'll have this, and therefore we don't need a handle click anymore. There we go. We do something and nothing changes anymore because nothing's hooked up yet. But here we're gonna, in our vue.js one, we are going to do something similar. So in our square, we're gonna define additional prop, which is on square click. And instead of calling handle click, we'll just say, hey, on square click. I mean, I guess it'll be props, right? There we go. And again, nothing yet. I don't know if I've ever tried to actually pass a function like that, like a callback in Vue.js. That's new. So now we'll connect the onSquareClick prop to a function in the board component that you'll name handleClick. To connect onSquareClick to handleClick, you'll pass a function to the SquareClick prop of the first square component. Just like that. So lastly, you will define the handleClick function inside the board component to update the squares array holding your board state. So handleClick is just next squares is square slice. Next square 0 is X. Set squares. Wait a moment. What? The handleClick function creates a copy of the squares array. The next squares. Okay. With a JavaScript slice array method. Then handleClick updates the next squares array to add X to the first 0 index square. But that will just keep changing just one. What the hell? I mean, we can just go here and do that. I'm just very confused. Like, why would we do it that way? On click. Wait, that was not on click. That was on square click. And yeah, handle click. Now in here, we just need to define function handle click, and we do nothing. And we'll just have the thing where we just do this. It just sets to the 0 element. So it always, no matter where I will click, the first one will select. Yeah. So that's where we will need to start attaching extra data. So I guess that's when suddenly we'll need to start wrapping things, I guess. Let's see how React does it before I implement it in Vue.js. The handle click, yeah, it does that, right? Calling the set squares function lets React know the state of the component has changed. This will trigger a re-render of the components that use the square state, which is all of them. Square state board, which is board, as well as its child components, square components that make up the board. JavaScript supports closures, which means an inner function, for example, handle click, has access to variables and functions define an outer function, for example, the board. The handle click function can read the square state and call the set squares method because they are both defined inside of the board function. Now you can add X's to the board, but only to the upper left square. Your handle click function is hard-coded to update the index of the upper left square. Let's update handle click to be able to update any square. Add an argument I to the handle click function that takes the index of the square to update. Okay, so our handle click will have this, and we'll set the I, right? Next, you will need to pass that I to handle click. You could try to set on square prop of square to handle click 0 directly in JS6, like this, but it won't work. Yep, here is why this doesn't work. The handle click 0 call will be a part of rendering the board component. Because handle click 0 alters the state of the board component by calling set squares, your entire board component will be re-rendered again. But this runs handle click 0 again, leading to an infinite loop. Too many re-renders. React limits the number of renders to prevent an infinite loop. There you go. Why didn't this problem happen earlier? When you were passing on square click, handle click, you were passing the handle click function down as a prop. You were not calling it. But now you're calling that function right away. Notice the parentheses and handle click. And that's why it runs too early. You don't want to call handle click until the user clicks. So we'll need to wrap it probably. You could fix this by creating a function like handle first square click that calls handle click 0, a function like handle seconds. Oh dear God. And so on. You would pass rather than call these functions down as props like this. This would solve the infinite loop. However, defining 9 different functions and giving each of them names is too verbose. Instead, let's do this. There we go. We just need to define a function here. Yuck. Okay. Let's do it then. We just add I, and we do I. And now everywhere we have handle click, we're just gonna say, hey, you know what? We'll do this, and let's start from 0. And 1 and 2. I mean, in theory, we could just call it from within the block itself, right? Not the best practice, but could work. Save, and now this should work no problem. There we go. Okay. So notice the new syntax here, the arrow function, whatever. It's an arrow function, which is a shorter way to define functions. When the squares click, the code after the arrow will run calling handle click 0. Excuse me. Now you need to update the other 8 squares to call handle click from the arrow functions you pass. Make sure that the argument for each call of the handle click corresponds to the index of the square. There we go, it works. But now you can again add access to any square on the board by clicking on them. Yeah, now you can, yeah. This time all state management is handled by the board component. This is what the code should look like. So now that this is working here, let's, well, do it here. I guess this times out after a moment. So annoying. So what this calls it, right? Props on square click. Okay. So we just need to do the same thing here. And let's just do constant handle click, which will be a function that takes an I, right? And what we can just do the same code as we had here. There we go. We copy squares, right? The next squares is this. And then instead of set squares, wait, what the hell did I do here? And then the set squares will be not that anymore. We just do squares is this. But I want the value. This is the key here. I don't think we need to set value here. There we go. And we need to pass that prop. So that's gonna be new. What the hell was the name of it? On square click. On square click. And this will be handle click. I wonder if this is gonna work the same way, because I mean, we're passing the prop, so I guess we need to do exactly the same thing. Because we're not defining events how you would normally do it. So that's the difference. You go away. So many things try to open up. So annoying. Makes me mad. Okay. Now it doesn't work. Why was it? What did I do? There we go. Now it's fixed. Okay, so you can see that this dot value, whenever we deal with the reference, whenever we read from it or write to it, we need to use this value. But we don't have to do that within the template. So that's the weird part about Vue.js that I don't like. That there's this kind of difference between the two. But the nice thing about it is you can use that ref like outside of your normal component, which is fun too. All right, so we have the same thing. Now that your state handling is in the board component, the parent board component passes props to the child square component so that they can be displayed correctly. When clicking on a square, the child square component now asks the parent board component to update the state of the board. When the board state changes, both the board component and every child square re-renders automatically. Keeping the state of all squares in the board component will allow it to determine the winner in the future. Okay, let's recap what happened when a user clicks top left square on your board to add an X to it. So first, clicking on the upper left square runs the function that the button received as its on-click prop from the square. The square component receives that function as its on-square click prop from the board the board component defined in the function directly in the JSX. It calls handle click with an argument of 0. Then we have the handle click uses the argument 0 to update the first element of the squares. And from array from null to x, the square's state of the board component was updated, so the board and all of its children re-render. And this causes the value prop of the square component with index 0 to change from null to x. In the end, the user sees that the upper left square has changed from empty to having an x after clicking it. Yep. The DOM button elements on click attribute has special meaning to React because it's a built-in component. For custom components like square, the naming is up to you. You could give any name to the square's on-square click prop or board's handle click function. And the code would work the same. In React, it's conventional to use on-something names for props which represent events and handle something for the function definition which handle those events. Exactly. So why immutability is important. Note how in handle click you call slice to create a copy of the squares array instead of modifying the existing array. To explain why, we need to discuss immutability and why immutability is important to learn. There are generally two approaches to changing data. The first approach is to mutate the data by directly changing the data's values. The second approach is to replace the data with new copy, which has the desired changes. Here's what it would look like if you mutated the squares array. We just mutated it and bam. The thing is, React won't detect that, right? And here's what it would look like if you changed data without mutating the squares array. Okay. Now squares is unchanged. The result is the same, but not mutating, changing the underlying data directly. You gain several benefits. Excuse me. Immutability makes complex features much easier to implement. Later in this tutorial, you will implement a time travel feature that lets you review the game's history and jump back to past moves. Yeah, this definitely will make the immutability handy because you will be just keeping track of those previous states. So, sure, it's just tied to a feature. This functionality isn't specific to games. An ability to undo and redo certain actions is a common requirement for apps. Avoiding direct data mutation lets you keep previous versions of data intact and reuse them later. There's also another benefit of immutability. By default, all child components re-render automatically when the state of parent component changes. This includes even the child components that weren't affected by the change. Although re-rendering is not by itself noticeable to the user, you shouldn't actively try to avoid it. You might want to skip re-rendering a part of the tree that clearly wasn't affected by it for performance reasons. Immutability makes it very cheap for components to compare whether their data has changed or not. Exactly, because we have like the same reference. You can learn more about how React chooses when to re-render a component in the memo API's reference. I'm going to open it up in the background because that's something I really want to know. So I just wanted to kind of update. Oh, dear God. Again. Code Sandbox, you absolutely suck. Okay, so I just wanted to update a square to be a little bit more vue.js-like, because right now we're passing a function as a prop, something you don't really do often in vue.js. It's more thematic to define actual event, so things act more like actual buttons and stuff. So we can just do something like constant emit which is define emits. And in this case, we just want emit like click. Maybe clicked or something like that. And therefore, here we can just simply do something very simple. So on click, we'll just do emit dot clicked. And that'll be it. Wait a moment. What am I doing? Sorry, I'm a little bit distracted. There we go. And we actually don't need to pass it in a value, so we should be okay. Ooh, yeah, right. There we go. So that will be clicked, and now we have more problems. What the heck is going on with this code? I'm getting so confused. We're not passing anything. Oh, right. Clicked. So when we clicked, we can actually do something of this sort. We can replace all this. And this, for some reason, what the heck just happened? There we go. We can still do the same thing, right? The thing is that we have explicitly defined an emit that is clearly an event. Therefore, we know that, oh, we can kind of react to it with this. You can imagine it on-clicked, right? Which makes it that, when I do at it, normally IDE will show it for me, right? I don't know if this will be smart enough. No, this one is not smart enough here, but it would show me that, hey, on Square, you can actually subscribe to a clicked event. And notice that we actually can just call it here, because this doesn't mean that, oh, this is getting called every time we render. This is called only when clicked happens. So we just run it. And that's it. We could pass a function that will receive whatever the emit puts in here, maybe 1, 2, 3, right? But I believe we can just do even something of this sort. It will still work. Yep. Refresh. And it still works. Yep. Just like that. So that's the nice thing about it with those emits. The only bad thing is you need to define it. But again, when you're defining it, you can add extra stuff that's happening. And you have kind of clear contract that, you don't have to rely that something starts with on or whatever. You kind of have separate props and have separate emits. Maybe React also has emits. I don't know. Haven't learned about it yet. Alrighty, so let's continue. Now we have the subject of taking turns. It's now time to fix a major defect in this tic-tac-toe game. The O's cannot be marked on the board. You'll set the first move to be X by default. let's keep track of this by adding another piece of state to the board component. So it'll be X is next. It'll be either true or false, right? That's it. It's that simple, right? And this will be living in the board. So like the entire thing knows, the sides, and we'll be probably passing it. No, we won't be passing it. We'll be just using it within the handle click, right? So yeah. And then each time a player moves is next, a boolean will be flipped to determine which player goes next, and the game state will be saved. You'll update the board's handle click function to flip the value of is next. So yeah, on handle click, we'll just have, hey, if X is next, add the X, otherwise, add O. And then we flip the value, and that's it. So basically, after we, before we set this stuff, right? Set squares. We're just doing it straight up here. If X is next, right? We're gonna set this to X. I don't like that. Let's do it more civilized ways. Next squares I is X is next. X, otherwise it will be O. There we go. Why add million lines? And then we'll do set X is next to the value of not X is next. Whoa. And that should be it. This is ugly. Now you click on different squares, they will alternate between X and O, as they should. Okay, so let's see. Oops. I'm doing 1 instead of I. We can override it, haha. So that's another little thing that we'll need to fix. But let's add it to vue.js, and it's all again within app.vue because we have very similar setup. So constant X is next. It'll be just reference to true. And here we're just gonna say same thing. X is next. And will be X or O. And the only thing is that after we set the next squares, we do X is next, not X is next. Notice how here we are actually mutating the state, but behind the scenes, it replaces it. So we have history, kind of, but it all happens behind the scenes. We can just change it. Although I just need to do this stupid value thing. Which is real ugly. But it works. There we go. We have the same behavior, the same bugs. But wait, there's a problem. Try clicking on the same square multiple times. There we go. The X is overwritten by the no. While this would add a very interesting twist to the game, we're going to stick to the original rules for now. When you mark a square with an X or no, you aren't first checking to see if the square already has an X or no value. You can fix this by returning early. You'll check to see if the square already has an X and O. If the square is already filled, you will return in the handle click function early, before everything. Yep, there you go. So we just go here. If X is, if squares I is not null, is null, is null, return, and we'll just do a one-liner, right? And here we'll have very similar thing. if squares dot value, and now we take the I, is null, and I'm using just double to, just in case, get either null or undefined value, return, right? We don't need to do anything else. Oh, wait, if it's not null, sorry. There we go. But now I can't change this one anymore. Yeah, now it'll be O. If I click on this one and do here, it still does O. X, O. I click many times, it still does X. So it works. Great. And here, we just need to fix that, right? There we go. Refresh. Yep, that works. Lovely. Now I can only add X's or O's to empty squares. Here's what your code should look like at this point. Yep. So declaring a winner. Now that the players can take turns, you'll want to show when the game is won, and there are no more turns to make. To do this, you'll add a helper function called calculateWinner that takes an array of 9 squares, checks for a winner, and returns X, O, or null if as appropriate. Don't worry too much about the calculateWinner function, it's not specific to React. Yeah, we have the lines, and we basically go over all the lines and check if they're all the same thing. And if they're all the same thing, just return that. So there are what 8 possible win conditions. So we'll just copy that, right? There's nothing special about it. So yeah, I'm just gonna, where do they want to put it? After the board. Okay. So after everything, we're just gonna add calculate winner here. I will throw it in here as well, but this reads from top to bottom. So I'm going to just throw it somewhere in here before the handle click, okay? And instead of doing that, I'll just do constant calculate winner is this. There we go. All right. And we just pass it squares, and therefore it wants to collide with this. I don't like that. SQS. SQRS. There we go. Whatever. Great. It doesn't matter whether you define calculate winner before or after the board. Let's put it at the end so that you don't have to scroll past it every time you edit your components. We will call calculate winner squares on the board component, on the board component's handle click function. Excuse me. To check if a player has won. You can perform this check at the same time you check if a user has clicked a square that already has an X and O. Would like to return LA in both cases, so either of this or that. And we pass in the squares. Okay. So in here will be, yeah, so we'll check if it's true, right? Or calculate winner, and we pass in the squares. Okay. That's simple enough. And this will basically calculate the winner every time we kind of try to handle the click. But that means that when we click something, we would need to handle again to show somebody won yet. And don't like that placement. And in vue.js, we can do something very similar whenever we do handle click. We'll also do calculate winner, and we're gonna pass in the squares.value. There we go. So I'm going to do this. I shouldn't be able to click anymore. Yep, so we've got a winner. Alrighty. Oh, so probably inside our calculate winner, we're gonna do like setting something? No, that doesn't make any sense. Huh. So that's that, right? To let the players know when the game is over, you can display text such as winner X or winner O. To do that, you'll add a status section to the board component. The status will display the winner if the game is over, and if the game is ongoing, you'll display which player turn is next. So basically, we can have constant winner, calculate winner, let status, if winner, do stuff, blah, 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 and then return status. Wait a moment. Because it's gonna be running every time the thing re-renders, right? Oh, I see. So basically, because this is inside board, this all like runs every time stuff re-renders, right? So we can simply do this. Hey, the board re-rendered because we changed some kind of state. Okay, we need to re-render, so we are recalculating this. That means that when we click something, it did calculate winners to see if we can click. Then it changed stuff and runs calculate winner again because it renders. And we just don't have any side effects here. I see. I don't like that. To be honest, I do not like that. So we just throw it in here and we'll just say next player this, right? So I'm going to do this. Bam, see, winner is X. But it's kind of hard to read, like, oh, this is suddenly calculated here. We're doing some actual calculations rather than stuff. The way I would do it in vue.js is I would just say constant winner is computed. Okay. And what we're doing here, computed. So we need to import computed. This is kind of something that automatically reacts to whenever state changes. So in this case, we just will react to the squares, right? So instead of calculate winner, we will literally do this. We'll put all this code in here. We calculate the state, and we won't be passing the squares in here. I mean, we can kind of do const squares because I don't feel like rewriting is squares to the value, right? So we just don't have to repeat that every time. So we've got a value here, and because we are reading that here inside components, it automatically just knows that, oh, we used it here. So every time this changes, this will automatically trigger and keep itself up to date. So we do this, that, and we'll return null. Otherwise, it will return proper X or O. And that value will be cached every time we read it until squares actually change. So we don't need this anymore. And we don't need to calculate. We just say if squares value this or winner is not null. Okay? Or like winner. And we need our little div to display it. In this case, not status, it'll be just winner. We saved it and it doesn't like it. What the hell is going on? class status. That doesn't make any sense. What the heck? It'll be nice to see the console. What mistake I made. Nope. Nope. Do we have anything else? No. Debug terminal? Nope. Whoops. Oh, this thing makes me angry. Very, very, very angry. Let me quickly check what the hell am I doing wrong. Yep, yep. This could use some indentation. Line's length. Wait. Oh. Oh. Did I just miscopied the thing? Why does it say winner here? Oh, because we're just putting it here. Duh. So I would just do it a little bit more. No, I mean, we can just straight up do it like this, right? Instead of returning this, I would just say winner is. We can even do this fancy stuff. Well, here is. Wait, they did next player, right? And what is next? That's it. So otherwise it'll be next player is. Oh no, just next player, and we just do X is next. And we would have to do that, but I don't like that because that means that whenever the X is next changes, this needs to recalculate. So this sucks. So let's do it properly. This is null. This is thing. So the thing is that you can approach doing something like that in so many ways. I would probably just say constant winner label because that's kind of nicer, computed. So that will be updating the label every time one of those changes. It doesn't recalculate it, so we'll do return and do X is next. So depending if X is if it's X, oh wait, if winner, right, is not null, then we're just gonna do return winner is, and we just do winner. Okay. Otherwise, we're gonna, depending on if, otherwise we're gonna return next player. And we're gonna do it here. X is next. Will be X, otherwise it will be O. And that's it. So the benefit of this is that the benefit of this solution is that basically this, let's call it heavy calculation, happens only when squares change, which is the actual data that drives it changes. If something like X changes, nothing happens. This only recalculates when squares change, while the label to display changes only whether the X is next changes or when the actual data from that recalculated from this actually changed. If it recalculated the same thing, this won't be triggered. Okay. This way we kind of skip recalculating this extra many times because X decided to change, right? So that's that. And therefore here we can do winner label. We'll save it. Winner is object. What? What the heck? Winner is supposed to be null. There we go. The stupid value. There we go. Oh, we still have a problem. Can't click it. Where else did I miss the value? That's good. That's good. There shouldn't be any of that here, so that's good. Handle click winner dot value. There we go. And we can change it. And if we're gonna make X win, will be winners X. We refresh. We're gonna make this one winner. There we go. So that works. Okay. This is where we have vastly different approach to make it, like nice. Personally, I don't like this because it's just random code that just goes. I know, I just personally don't like it. Congratulations, you now have working tic-tac-toe game and you've just learned the basics of React 2. So you are the real winner here. Here is what the code should look like. Yep, that was pretty easy. So adding the time travel. As a final exercise, let's make it possible to go back in time to the previous moves in the game. So storing a history of moves. If you mutated the squares array, implementing time travel would be very difficult. However, you use slice to create a new copy of the squares array after every move and treated it as immutable. This will allow you to store every past version of the squares array and navigate between the turns that have already happened. You'll store the past squares arrays in another array called history, which you'll store as a new state variable. The history array represents all board states from the first to the last move, and it has shape like this. So yeah, it will be first state, second state, third state, right? This X was added here, O was placed here, and whatnot. Lifting state up again. You will now write a new top-level component called game to display a list of past moves. That's where you will place the history state that contains the entire game history. Placing the history state into the game component will let you remove the square state from its child board component. Just like you lifted state up from the square component into the board component, you will now lift it up from the board into the top-level game component. This gives the game component full control over the board's data and lets you instruct the board to render previous turns from the history. Okay. So first, let's add a game component with export default. Have it render the board component and some markup. So again, after the board, we're just gonna say game and some markup. We'll take a look at it. All right. So after all this, before the calculate winner, we're just gonna plop it here. So we have the game function, right? Return. Oh, so this one can't be export default anymore. So it'll be just a function board. So we have the game, and here we have the game class. We have the game board in which you have the board, and then we have the game info, which right now has a list with nothing. We can just literally say to do, and it's not happy about it. To do. There we go. Beautiful. So we know that will show up on the right. So we can do something similar, right? In Vue. So in this case, we have the app view. So let's just extract all this into like separate board component. So component will be board.view. So that will be it. There we go. It's all in here. And therefore, when using the square, we just need to change it. There we go. And now in our app, we want this to exist. So I'm just gonna copy it and adapt it quickly. So this will be our game, whatever. So our game component, let's go to the template. This should be relatively simple. Oof. Can we just, oh, it doesn't have formatter built in. Great. So we've got this with board in here and something like this. Wait a moment. There we go. And instead of class name, we just have class. Okay, we put in the board, so we need to import it. We don't need all of this. We'll just import the board from board. And to do. There we go. We've got the same thing. So that was relatively easy. We moved that into a separate component. Normally the app.view, there's like barely anything here. Everything just put into components. I'm sure it's the same with React. It's just for the tutorial they did it the way they did. So note that you are removing the export default keywords before the function board declaration and adding them before the function game declaration. This tells your index.js file to use the game component as the top level component instead of your boards component. The additional divs returned by the game component are making room for the game information you add to the board later. All right. So add some state to the game component to track which player is next and history of moves. Okay, so is next, we're just placing here. And then our history will be here. So the history will be a list of those arrays. And we start with the empty array here. I see. So in case of our React, we'll actually place it here, right? That means that our state is no longer here, right? This shouldn't really have access to that. And the history is placed straight up in here. Can I fold this? Okay. Can I take my square? Because I don't think we'll be modifying the squares themselves here. So yeah, that's that. Now let's kind of add those two to our vue.js thing. We know that in the board we already had squares and is next defined. So we can kind of copy them and place them here. We can even rearrange it like they had before. So is next, x is next, we have as true. I don't like x is next. It should be is x next, or is next x. Square, and no, this will be an array with that element, so that we have first element of the history, right? And notice how array, array with an array of those 9 nulls is an array with a single item, which itself is an array of 9 nulls. To render the squares for the current move, you'll want to read the last squares array from the history. You don't need useState for this. You already have enough information to calculate it during rendering. So basic in the game, the current squares is history and take the last element, right? So, and then we'll be able to pass it on to something else. So, wait, where's our game here? So we'll just say, hey, this is the current squares, right? And the next create handle play function inside the game component that will be called by the board component to update the game. Pass is next current squares and handle play as props to the board component. Okay, so this is basically, in the board component, we'll basically say, hey, use this as x is next. This will be our current squares, right? So that will be instead of squares, it will be current squares. And I mean, it will rename it as squares, right? And we just pass on squares, so the stuff inside of the board won't change. And on play will be our basically callback to whenever we make a play, we don't actually have that code inside the board anymore. So yeah, we just plop it here. We just need to take that handle play and put it in here as well. All right. So that should be it. The only thing is we need to make the board actually accept it. So it'll be x is next, squares, and on play, or what was it? On play, yep. And that means we don't use those anymore. Bam. When we save it, it will like not work because, oh, we don't have such thing as set squares. Yep. Okay, let's make the board component fully controlled by the props it receives. Change the board component to take 3 props, x is next, squares, and on play function. That board can call with the updated squares array when a player makes a move. Next, remove the first 2 lines of the board function by call useState. And there we go, we've got that. Now replace the set squares and set x is next calls and handle click in the board component with a single call to your new onPlay function. So the game component can update the board when user clicks square. So there we go, and handle click. We do all this fun stuff and we call onPlay and what are supposed to next squares be. Okay, so the board will basically handle what to pass on. So it takes that, still has that responsibility. So instead of set squares and all that, we'll just do on play and we're gonna pass in the next squares. And because we just called that, hey, this thing needs to happen, we don't need to change the is next and whatever manual here. This will happen inside the other one. So the board component is fully controlled by the props passed to it by the game component. You need to implement the handle play function in the game component to get the game working again. What should handle play do when called? Well, we need to add this thing, the state to the new state to the list. Then we need to add switch the x is next. And that's it, right? Remember that the board used to call set squares with an updated array. Now it passes the updated squares to onPlay. The handle play function needs to update the game state to trigger a re-render. But you don't have a set squares function that you can call anymore. You're now using the history state variable to store this information. You'll want to update history by appending the updated squares array as a new history entry. You also want to toggle is X is next, just as board used to do. Okay, so we basically create a new history object here. So we just create a new list with everything from history and next squares added at the end, and then set X is next. All right, and that's it. So I'm just gonna do that because this is just so simple. So yeah, on play, we go back to the game and we just put it in here, and that's it. There we go. It all works. X is a winner. So let's reload this, wait 30 years until it finishes, and you go away. There we go. So now instead of a game we are good, we just need to do the handle play, right? Const handle play. And we're gonna take in the new squares, right? And what we're gonna do is basically squares push new squares. We just added the history because, dot value, right? And then we also need to update the x is next. So x is next dot value is not x is x dot value. There you go. While the board itself needs to receive all those elements, right? So we need to pass it into it things like x is next, Oh, but we need to not send it a string. We need to send it the actual JavaScript value. There we go. The other one was squares will be the last square. So this is again where I would use computed constant current squares is computed. So we basically say squares dot value and we do squares dot value dot length -1. And that's it. So it will be the current squares. And lastly, it was the callback. So in this case, it will be on play or like just on play. We'll call the handle play. That would take the new squares. Okay. So this is what we have. We just need to update it inside the board. So I'm gonna just copy this to speed it up. So we'll define props, which will be, in this case, x is next. And squares. And that's it. And here will be just play as an emit. Okay. So we don't need the squares anymore. Or x is next. All that stays here. We'll be still computing the winner the way we were. The only thing is that now we kind of have to, fix those because we want the squares. Because it's not this ref anymore, it's just a prop. So that's the one thing that I don't like. You notice that how in React we were able to quickly doing it. And Jalil Wahidov says, what IDE are you using? I'm using literally a code sandbox right now because that's what an example came from the React tutorial. And looks like they're just wrapping around VS Code. So that's that. Okay, so squares, we did that. Blah, blah, blah. So in theory, we can just simplify it. So we just literally do squares here. Okay. Ooh, sorry. Propped up squares, it's even worse. I mean, you can kind of go around if you extract props into refs. There's like 2 refs and whatnot, but I won't be going into that because we'll be just introducing more and more and more. So let's do it the brute force way. So winner label, winner blah blah, but x is next, not dot value. We're doing props dot x is next. And here we're doing props dot squares. And we're doing the same thing. So whenever we have winner dot value, wow, in both spots. Props dot winner. And whenever we have squares value, we'll do props dot squares. And we have again this random thing. Props. And there we go. This should be fixed. And all this should work the way it worked. On click, we do handle click, but we're not actually setting those anymore. Now we want to do something else. We want to do emit, and we want to emit the play event, and as a value, we're just gonna give it the next squares. There we go. That's it. Okay. All right. Is it everything, or did I miss something? Because this, it might work. Winner is undefined. Oops. So props. Oh, sorry. Winner is local, right? Winner at value. There we go. Same here. Winner dot value. See, so that's the confusing part that I don't enjoy. So we refresh and there we go. All that works. Beautiful. Okay, so we just copied that. So now here, okay, so this is where we were doing this whole fun thing of appending to history. I guess we haven't done that yet, right? So we had this part. Unless we did that already? Did I do that? I might have. Oh yeah, I just did that. It's just not squares. This should be history, right? So history, we're pushing into history. There we go. And there we go. Now it's a little bit more like it's supposed to be. So here the history next squares creates a new array that contains all the items in history, followed by next squares. You can read that whatever. Spread history, as in spread syntax, as enumerate all the items in history. Yep. For example, history. Okay, I can skip that. We all know basics of JavaScript. At this point, you've moved the state to live in the game component, and the UI should be fully working, just as it was before the refactor. Here's what the code should look like at this point. And now showing the past moves. Since you are recording the tic-tac-toe game's history, you can now display a list of past moves to the player. React elements like button are regular JavaScript objects. You can pass them around in your application. To render multiple items in React, you can use an array of React elements. You already have an array of history moves in state. So now you need to transform it to an array of React elements. In JavaScript, to transform one array into another, you can use the array map method. Yep, so we just say 1 to 3 map times 2 and we double it, right? You'll use map to transform your history of moves into React elements representing buttons on the screen. And display a list of buttons to jump to past moves. Let's map over the history in the game component. So export default function game, constant x is next, right? You state true. So we have all that stuff here. So handle play, wait. display a list of button. Oh, wait, this is the new stuff. It looked like this is the only code. Okay, yeah, jump to, which is next move. And then we have the moves, right? Which will map over the history. We'll get the squares and move as the index. And we'll basically say, go here, go there, do that, right? And that's it. Okay, so let me copy that and we'll just paste it and look at it in here so that it looks a bit nicer. So this is the board. We don't care about the board anymore. I think we won't be touching it anymore. So now what matters is that we have our jump to, right? Which will be, I guess, used to we click on a button and it jumps there. So our moves, we map over the history. We get our, history element, which will be just set of squares. And this should be just an index. So it should be 0, 1, 2, 3, right? As we're iterating. So we extract the description. If it's move rather than the first one will be go to move, bam, right? And the index. And because it's not the 0, it will be just 1 in here automatically. So we don't need to do any +1. But if it's no larger than 0, it is 0, like it's the first move, we'll just do go to the game start because that will be the first element. And then after we have all this, then we're gonna basically run with this. So we could do something similar. And of course here we can just print out the list, which will be moves, right? There we go. We've got those moves and they all are just a button, like a list item. Button, and when we click it, it just executes that jump to with a specific move, the index that's still in here because it was still within the map, and just slaps on a description. So, okay, let me copy this, or maybe not copy, because now how do we implement that in vue.js? I would again go with simple combination of things. First of all, I would say that we want to do something similar that they did. Notice that first we calculated what is the description and kind of what is the index for each item, right? So in theory, we could do something similar. I'm just thinking if it's needed. Yeah, I would probably do that here. Yep. So let's do that. Let's call it jump button data. Okay, whatever. It'll be data specifically for displaying those buttons, right? So we'll make it computed. And because of this will be computed, it will be updating, like recalculating, refreshing itself only whenever history changes. So it's, it's automatically memoized. So in this case, we just want to go over each element. So we're gonna grab our, let's say, return. What we're gonna return is history.map. Very similar, right? We take our squares and I know I'll just call it index because that's what I like to call that thing. But what they had, well, move. It's an index, right? I can actually copy all this and it should work, right? Let's just do history.value because, of course, it bugs me today. Really. So the description will be this, if move, and that. Let's simplify it. We want to return actual object for each item, instead of stuff. So we're gonna have this, and this will be another closing thing. So what we're gonna do is that this description will be what? Move is 0. If yes, will be go to game start. Otherwise, go to the index. While then we have index, which is just index. And that's it. Okay. So to make it prettier, we can do something fancy like that. So this is the description. This is the index. And there we go. There we go. There we go. Beautiful. So we just returned a new object for each history element. So we should have basically a list of objects, description and index. So this is purely data. This is not like recalculating all the whatever list items. So this is where we can do this in here. So what we're going to do here is, wow, this just freaked out. Why? This is making me angry. Oh, no error, just this whole thing freaks out. So annoying. So what we're going to do here is very, very, very simple. We'll just do a list item, right? Because we want to render it as list item. What else did we have? Like, let's say a single button. A single button would be something like this. Button, on click to this and or that or whatever. Oh, we need our jump. Constant on jump, which will be a function which takes in the whatever history index, right? And does something. We don't care what it does yet. So instead of on click, we just do at click. And this will be just jump to. And it will automatic. Oh, and we just need to, of course, give it the not move. This will be, we'll get there in a second. Well, description will also get to that in a second. So what happens is with those list items, we can just do v4. So we're just going to do a loop. And that v4 will be something like, oh, this will be for jump button entry, right? We'll call it jump button and entry in jump button data. So this is like, iterate for all the elements in there and will be just as entry, right? So jump to this dot index. And here we have this dot description. So we can reformat a little bit nicer. We'll save it. And now, of course, it doesn't work for some reason. Isn't it funny how in React somehow it works, here it doesn't work? Unless I need to refresh again. No, now we're actually getting proper error. Look at that. Oh, because we need to do this. I don't know. That's weird that it works that way. Nope, it straight up doesn't work. What the heck? Does it really complain about the key? I mean, not here. Here. That'll be the funniest thing if it actually complained about that, but no, it's not the thing. Hello CPN. Look at that. CPN, I didn't have to go through all of this when I made a tic-tac-toe in Vanilla.js. Just saying. Move it to VS Code, that might fix it. Yeah, I don't feel like setting up entire VS Code right now. Just, I know I made some little something somewhere that is just absolutely silly. But where is my error? Must be somewhere here. History value. Yeah. We map over those. We create a new element. Description and index. And all of that. I wonder if I'll open it, what was it, as a separate, open a new tab. Will that allow me to actually debug it? Oh, wait, I have moved somewhere still? Where is my move thing? Move. Oh, huh. Index. There we go. What the heck? Refresh. There we go. Go to game start. So now we have it working. There we go. So right now these don't work yet, but that will get fixed. But hey, that works. Yay. No dev tools. Yeah, kind of. This is like this whole code sandbox is just like half broken. Don't understand. Don't care. It's just weird. Whatever. That's what React tutorial started with, so that's what I'm going with. But I'm nearly done with the tutorial. So you can see what your code should look like below. Note that you should see an error in developer tools console that says, warning, each child in an array or iterator should have a unique key prop. Check the render method of game. Yep, that's what I already took care of in vue.js. So here we're basically, okay, we have the whole code. Okay, no big deal. As you iterate through the history array inside a function you pass to map, the squares argument goes through each element of history, and the move argument goes through each array index from 0, 1, 2, etc. In most cases, you'd need the actual array element, but to render this list of moves, you will only need indexes. For each move in the tic-tac-toe game's history, you create a list item, which contains a button. The button has an on-click handler which calls the function called jump_to that you haven't implemented yet. For now, we should see a list of moves that occurred in the game and an error in developer tools. Let's just discuss what the key error means. So picking a key. When you render a list, React stores some information about each rendered list item. When you update a list, React needs to determine what has changed. You could have added, removed, rearranged, or updated the list items. Imagine transitioning from Alexa 7 tasks left, Ben 5 tasks left, to Ben 9 tasks left, Claudia 8 tasks left, and Alexa 5 tasks left. In addition to the updated counts, a human reading this would probably say that you swapped Alexa and Ben's ordering and inserted Claudia between them. However, React is a computer program and does not know what you intended. So you need to specify a key property for each list item to differentiate each list item from its siblings. If your data was from a database, Alexa, Ben, and Claudia's database ID could be used as keys. So list item, key, user ID, right? And then we have the user and task count left. When a user is re-rendered, React takes each list item's key and searches the previous list item for a matching key. If the current list has a key that didn't exist before, React creates a component. If the current list is missing a key that existed in the previous list, React destroys the previous component. And if two keys match, the corresponding component is moved. So we don't need to go through the process of destroying something and adding something. Even though we're looking for a match, it's still, cheaper, faster. So the keys tells React about the identity of each component, which allows React to maintain state between re-renders. If a component's key changes, the component will be destroyed and recreated with a new state. Yeah, so that's another thing. We're maintaining the state between the things. If we swap them, each component will keep their state instead of maybe randomly updating the title, but state still being the same. You would have like weird errors. Key is a special and reserved property in React. When an element is created, React extracts the key property and stores the key directly on the returned element. Even though key may look like it's passed as props, React automatically uses key to decide which component to update. There's no way for a component to ask what key is its parent specified. Oh, so we don't have access to it. It's strongly recommended that you assign proper keys whenever you build dynamic lists. If you don't have an appropriate key, you may want to consider restructuring your data so that you do. If no key is specified, React will report an error and use the array index as a key by default. Using the array index as a key is problematic when trying to reorder our list items or inserting/removing list items. Explicitly passing key I silences the error but has the same problems as array indices and is not recommended in most cases. Keys do not need to be globally unique. They only need to be unique between components and their siblings. Okay, so we'll actually add it. So implementing time travel. In the tic-tac-toe game's history, each past move has a unique ID associated with it. It's the sequential number of the move. Moves will never be reordered, deleted, or inserted in the middle. So it's safe to use the move index as a key. In the game function, you can add the key as a list item, and we specify key is move. And if you reload the re-rendered game, React's key error should disappear. So that's it. We just and when we render our list items, we just add the key to the index, right? And that's it. And in vue.js, which I need to reload once more. What a joke. In here, I already added it. So when we render it, we specify the key to be the index. There we go. Okay, great. So we've got the whole thing. Before you can implement jump to, you need the game component to keep track of which step the user is currently viewing. To do this, define a new state variable called current move, defaulting to 0. Okay. So constant current move, set current move. Okay, so we're just... Why are we tracking like that? Okay, we've got a current move. We start from 0, of course. Oh, probably so that we check, we move somewhere, right? We can view it, we can get back to whatever we wanted. But the moment we kind of, let's say, go back in history and make a move, we will probably delete the rest of the history and start from that point. Okay, all right. Next, update the jump to function inside the game to update that current move. You also set the x is next to true if the number that you're changing current move is even. Okay, that makes sense. So yeah, basically in jump 2, we'll set the current move to the next move and set x is next to basically, module 2. If it's 0, that means it's even, and that's it. Okay. So suddenly we'll be able to do this and kind of set the value, right? When we click on it, you can see how the next player changes. Alrighty. Easy. You will now make 2 changes to the game's handle play function, which is called when you click on a square. If you go back in time and then make a new move from that point, you only want to keep the history up to that point instead of adding next squares after all items. So the spread syntax in history, right? You'll add it after all items in history. So history slice from 0 to the current move, right? So that you're only keeping that portion of the old history. Each time a move is made, you need to update current move to point to the latest history entry. Okay, so in handle play, we have the next history. We basically recalculate that. And then we just set it, right? And set current move to be the last one. Okay, I mean, that's simple enough, right? Nothing surprising here. Bam. And the set next, it's all good. So yeah, we're just splicing that, slicing x squares and whatnot. That should be it. Actually, I think we'll be able to already go here, and the moment we do that, yep, can go back to start and start adding stuff. And I mean, it won't do that now because the winner is x. So whenever we click something, we'll also need to load that state, right? As the current state. Finally, you will modify the game component to render the currently selected move instead of always rendering the final move. So the current squares is history, current move. Yep. So current squares is history, and not doing that, it will be the current move. There we go. So we refresh that. We do those things, and we can go here. Or we can go back and forth, right? So go here, and we can just bam, and we just rewrote that history. Very, very, very simple. CPN says the spread operator makes a copy of the array every time. What a waste of memory. Yeah, I mean, the whole idea here is to actually copy it, because the whole idea is that we're keeping the history of previous moves, right? Every time I do that, I actually keep that this state that it was in memory. And because it's so little to store, it makes sense. There's no need to optimize or do some complicated stuff. This way we can iterate on the stuff quickly. Okay, so while we have this, I need to re-implement that now in Vue. So let's copy the jump 2 and kind of replicate it. So on jump, we needed to set the current move and set the x is next to something, proper. And I already see an improvement to do here, to make here. Okay, so on jump, set the current move. So we basically need to start tracking the current move. So const current move is reference, and we'll start from 0, right? That's the current one. Therefore, current squares won't be this, it'll be this as the current move value, right? So we will have the current squares always up to date. And then we can actually do here the current move dot value is the next move, right? I mean, sure, a history index. There we go. And here we're setting the, x is next, value is the next move, which is the history index, if it's this. So in theory, instead of recalculating it here, what we can do is say, you know what, we don't want to specify like the x is next as the order to that we have to keep track to move it. And we can just redo some stuff. And CPN says it's giving me the ick to my Zig brain. It's insignificant. Oh, I know it's insignificant. Yeah, I know. I'm just laughing with you because, I understand that itch. All right, so X is next. Instead of just doing this, let's do it different. Let's say that this is computed value. Computed, and it will automatically compute itself to be basically the current move, the value. And what was it? Where the hell is it? Mod 2 is 0. So it will kind of automatically do that, compute itself, right? So we don't even need to do this here. The moment we change the current move, the is next is always going to update itself. Therefore, what else do we reference x is next? So the moment we'll be doing the handle play, I know that we won't have to set the x is next anymore because it's going to recalculate itself automatically. So we know that in handle play, we were adding this stuff to history, right? So let's just take a look in here and adapt it to this. So here we're just pushing to the history, right? But really we want to get the next history. We want to slice it, right? So it will be the history value, slice it, current move dot value, yuck, bam, and the next squares, the new squares. There you go. So this will be like the new value that we want to set. So that's that. And therefore we have the entire copy of history and we can just set it. So instead of doing the next history is this, we just do history.value is this. And here we don't do set history next history. We already have, whoops. Where did you come from? We just do that part and set current move. Now it will be current move value is the history.value.length -1. And this, because we set the current move, we update it, the is next is going to update itself automatically. Alrighty. This is good. Okay. So we went through that. We went through this. And wait, does it work already? Or did I make a mistake? Oop. Oh, just clicking. Yeah, it changes state. We just don't know which move we're on. But we can, go back and do all that. We can start a new game from scratch. Right? We click and we just have the first move added. Great. Okay. If you click on a step in the game history, the tic-tac-toe board should immediately update to show what the board looked like after that step occurred. Yep. So final cleanup. If you look at the code very closely, you may notice that the X next is true when current move is even, and the X is next is false when current move is odd. In other words, if you know the value of current move, then you can always figure out what the X is next should be. Okay, so they're talking about taking care of what I just did in vue.js. There's no reason for you to store both of these in state. In fact, always try to avoid redundant state. Simplifying what you store in state reduces bugs and makes your code easier to understand. Change game so that it doesn't store x is next as a separate state variable and instead figures it out based on the current move. So yeah, that's great, but because it's React, it's gonna recalculate it every time. So we're creating this array. I mean, not with useState, not with this, but this is gonna be calculated every time. This is gonna be calculated every time. A bunch of other stuff is gonna get calculated every time we re-render. I don't like that. With view approach, we go through this once, and that's it. And from that point, everything is event driven. We click something, handle play updates the history and the current move, right? And only then, even though some other stuff changed around, maybe we needed to re-render this, this component, nothing changed, so we just don't update the component at all. Only we don't touch x's next, we don't touch the current squares, right? We don't do anything with that. Or even jump button data, we don't recalculate anything there. Only when actually something changes, only then it gets recalculated. So, everything is properly memoized, like from the beginning. You don't really have an option of recalculating at every time unless you do something really dumb. And I know this would be a function of like get x is next, and right, and you're gonna call it here. So every time it re-renders, it needs to do this calculation. But that's like considered a bad thing in vue.js. So that's the thing I like. Sabine is asking, is there a reason why you're looking into React, or are you just exploring? Basically, I'm currently looking for a job. So, and as I'm going through all the job stuff, it's like, okay, I need some experience with React. I'm just like straight up shocked that 95 or maybe even more % of jobs, they all want React. And it's like, oh, this is a new project. We're looking for a founding engineer. We decided on React. And it's like, why are you deciding on React? As far as I know, it's like becomes very, very cumbersome the moment you get out of the simple tic-tac-toe example, because you need to, bend over backwards to start managing your state to make sure it doesn't re-render and recalculate everything so many times. And, I'm like, okay, let's see, maybe I'm just wrong. And starting a new React app is a good idea. But so far, it doesn't look like. Yeah, so it's like, yeah, but hey, I've heard that React is slowly, finally starting to drop. As, other frameworks, mostly Vue.js, even Angular is going up because they're starting to make the, Angular from being big enterprise behemoth is starting to modularize and be a little bit easier to start with. React finally is going down. Maybe finally people are realizing that, the limitations of React make everything overcomplicated. So, let's go through tutorials and figure that out. I want to finish that tutorial and maybe we'll look at thinking in React, and that'll be it for this time. And I'll probably go with another tutorial, another set of something to maybe go a little bit deeper, maybe actually implement something. It would be nice to make like a little maybe habit tracker kind of app instead of to-do. Let's do habit tracker with something more interesting and save data in a database or whatever. But yeah, we'll see. CPN says, Angular is worse. Every Angular web app I've used are dog shit. I actually started out in Angular. I started out in Angular. Wow, that was one of the first Angulars. And because I was already familiar with things like, C Sharp, ASP.NET, all those big frameworks, it was like, okay, I have similar dependency injections, similar this and that. So for me, I was already familiar with the patterns. But at the same time, there was just so much boilerplate, like so much. Then I looked into React. It was absolutely disgusting because I know it felt like unintuitive for me back then, but I wasn't that familiar with JavaScript at that point yet. And then I found Vue, and it was like, oh, this actually makes sense. I can make something small, I can make something larger, and my brain doesn't hurt. And ever since, I just liked it. I liked Svelte, but I found some additional limitations with that, especially when you start doing CSS stuff. I don't know, just the whole build process kind of annoys me. So I don't know, I found the vue.js to be like the good combination of good solutions from Angular without being all boilerplatey. Good, nice, nimble solutions similar to React without being, I know, constrained by everything being manual and functional. So, yeah. All right, let's finish this. So we did fix we need to fix the X's next, right? So instead of doing this, we could simply put that in here. Right. There we go. And in handle play, we don't have to set it. And in jump to, we don't have to set it, right? Bam. Bam. Because the whole thing will re-render, and therefore these will recalculate. This entire ugly thing will recalculate. Yep. Okay. So you no longer need the X's next state declaration or the calls to set X's next. Now there's no chance for X's next to get out of sync with the current move, even if you make a mistake while coding the components, unless of course you forget to set current move, but that will be disaster no matter what. Wrapping up, congratulations, you've created a tic-tac-toe game that lets you play tic-tac-toe, indicates when a player has won a game, stores the game's history as the game progresses, allows players to review game's history and see previous versions of the game board. Nice work. We hope you now feel like you have a decent grasp of how React works. I mean, very basic of how to use the basic tools, but yeah, final results. And if you have extra time or want to practice your new React skills, here are some ideas for improvements that you could make to the tic-tac-toe game, listed in order of increasing difficulty. First, for the current move only, show you are at move bam instead of a button. Okay, we could do that. So that would mean that in our moves, we're doing this, right? So we have the description. If move, we do go to or whatnot or whatnot. Okay. So we probably want to do it here. Okay, so go to move, go to game start. That's the go to. Is to let show button, right? Show button should be simple, which will be the current move is the same as move. Okay, so this will be our current like show button. And therefore we can say here when we render it, show button. If it's that, then we're actually plopping this in here. Or we could do even crazier thing, which is if show button, then do this, which is absolutely disgusting. Can I at least do it like this? And otherwise, we'll just do what? Span? And we'll just throw in the description and that's it. Will that work? Oh, wait. Show button, true. Bam. Not bam. Ooh, sorry. There we go. So we have this thing. Now we would just need to change from go to something like you are at. Since I have a go to, we'll just do you are at. Let prefix is if show button will be go to. Otherwise will be you're at. Okay, and here we're just gonna replace this with this and this. And instead of go to, we'll have the prefix. Whoa, prefix, what? Our game start. There we go. Bam, 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 bam. And we can always move back. There we go. Fixed. Rewrite board to use two loops to make the squares instead of hard coding them. We're hard coding them still. Where's the board? Oh yeah, we're doing that. Ouch. NCPN, why use let when you aren't mutating the values? Yep, that's true. I could do that. I'm just straight up not thinking right now. I don't feel like doing that. The loops are horrible. Add a toggle button that lets you sort the moves in either ascending or descending order. Oh, geez. When someone wins, highlight the 3 squares that cause the win. And when no one wins, display a message about the result being a draw. Okay. Display the location for each move in the format, row, column, and the move history list. Okay. I mean, I can see it. I just don't feel like doing that. Let's go to thinking in React and see if we can get through that today. But maybe that will just shed some light into like, oh, there are some additional patterns that I didn't catch within this very specific moment of whatever, this little tutorial. All right, thinking in React. React can change how you think about the design you look at and the apps you build. When you build a user interface with React, you will first break it apart into pieces called components. Then you will describe the different visual states for each of your components. Finally, you will connect your components together so that data flows through them. And this tutorial will guide you through the thought process of building a searchable product data table with React. Oh, so we're actually building yet another thing. I think I'll be finishing for tonight because this is like another tutorial that I would like to follow closely. But I'm tired, so we might finish for now. So usually I start at 10 of my time. And this time I started at 7, so we're already 3.5 hours. So yeah, I think that will be it for tonight. So next time we're gonna go through thinking in React. It should shed some more light into what's going on. And then we're gonna go through a rough installation and setup and start an actual project. I already know that I want to make some relatively simple like habit tracker where you can put in your habits that you want to track, maybe some fun little reward program, right? And just a way to see how you're following up with this thing. And maybe we'll make it save somewhere, not just your browser, but maybe in some way, I don't know, Terso or something like that. Get a database in there, throw that data in there, and see how that goes. And therefore, we can easily deploy it as an SPA, I hope, for free. And you have fully free app that doesn't cost you to host, works on your phone, and something else. Maybe we'll just throw in some basic React thing basic CSS thing to start working with, and yeah, make a little app. That'll be fun. So yeah, that'll be next time. So thank you CPN for joining. And yeah, see you next time.